Programming might be the single most important skill for data scientists and many other data practitioners. Coding allows you to construct predictive models, beautiful visualizations, and build products that scale to millions of people. This skill is extremely important, but actually learning coding is a massive barrier for those looking to harness its power. When I was starting out, I knew I wanted to leverage programming for data. Unfortunately, programming was such a large field that I didn't know where to start or what direction I should take. I knew I needed to get started, so I just pulled up Code Academy and went about learning aimlessly. At the time, I didn't know what languages were most practical, what concepts would help me in data analysis, or even what IDEs to use. I spent so much time just fumbling through different tutorials that I was really frustrated. I spent so many hours making stupid shapes move around on a page when I could have been doing and learning things that were more practical for my goals. So that you don't waste your time like I did, I'm gonna break down the essential concepts that you need to learn and why they're relevant for the data domain specifically. I start with some of the most basic skills and work the way up to a framework for learning almost any new advanced tool or concept. If anything, you're probably gonna wanna stick around to the end for that. Like always, the resources that I recommend will be linked in the description. Quick, is this a dog or a pastry? As a human, it's pretty easy to tell which is a cute puppy or a delicious muffin. On the other hand, even some advanced machine learning algorithms struggle with this distinction. Without advanced machine learning techniques, computers really struggle to do many tasks like this that are simple for humans. So why would we use computers for something like this? If we had to classify 10 images, a human would absolutely crush it. On the other hand, if we had to classify 5 million, we'd probably just throw up our hands and start eating the muffins to forget. Computers are incredible at doing simple tasks over and over again. This is illustrated by the first coding concept that I want to highlight. This concept is called flow control structures, and they're made up of loops and conditionals. A loop simply repeats a command over and over again. And we have two different types of loops. First, we have a for loop, and next we have a while loop. A for loop repeats an action a specified amount of time, while a while loop repeats indefinitely, often only stopping when a specific condition is met. For example, maybe we wanted to go through a transcript of one of my videos and count how many words there were. One approach to do this would be to write a loop to iterate through each word and just keep a counter. Loops are one of the most powerful tools in the data scientist's arsenal. They let us quickly iterate through data and manipulate it when necessary. Loops in a normal day-to-day data science workflow can be abstracted away through libraries, which we'll touch on later, but it's one, good to have an understanding of what's going on under the hood, and two, it's often really helpful to write one of these really quickly to aggregate, count, or do many other actions. Now, what if we wanted to count how many times I said papaya in any one of my video transcripts? This is where conditionals, another type of flow control structure, comes into play. Conditionals in combination with loops allow us to make some very powerful changes to our data. In most cases, conditionals allow us to do a certain action if a specific condition is met. In our papaya counting algorithm, we would do something like this. If a word is equal to papaya, add to a counter, else we don't count it. This way, we could count only papayas and ignore other words. The cool thing here is that we can have multiple conditionals to make our loop do very diverse things when confronted with specific scenarios. For example, we could have multiple counters, one for papaya, and maybe some other for fruits like strawberries. As you can imagine, flow control gives us a very powerful ability to manipulate and aggregate our data. I frequently use these concepts for data engineering and creating new features in my models. The syntax of a loop in Python looks like this, where we have for I in some range and then we do some action. You can loop through a list of numbers or any list in general. More on lists in a second. Conditionals generally take this form. So if we have some condition, we do this, else we do this other thing. A second ago, I mentioned lists. These fall into another very important concept for data science called data structures. You know as a data scientist that you're going to be working with a lot of data. Wouldn't it be better if it was organized in some logical way? Data structures allow us to organize the vast amounts of data so that it's easier to analyze, search, or alter. Some common data structures are lists, dictionaries, arrays, sets, and tuples. These are all native to Python, but different libraries that we touch on in a later section also introduce different data structures like series and data frames. Data structures are designed for a specific purpose. Let's take a list, for example. A list is a comma-separated collection of different data points. We can have a list of different numbers, words, objects, or a mix of these things in a list. Lists are easy to iterate through, and they're also mutable, which means that we can change the values at each point in the list. Lists can be great if we need to go through and make adjustments to our data at any point. For example, I might put my data into a list if I wanted to clean it up a bit. I could convert something to text and then maybe remove all the extra spaces or all of the punctuation, for instance. Dictionaries serve another purpose. So dictionaries allow us to categorize our data into specific headers. Just like a dictionary for words, We have a key, which is the equivalent of the word that you're looking up in a dictionary, and we have a value, which is the equivalent to the meaning of the word in the dictionary. These are also mutable. Let's say I wanted to go through my podcast, Ken's Nearest Neighbors, and do a count of each word that was said. I would loop through each word of the podcast and use a dictionary to catalog how many times each word was said. In this case, the key would be the word, and the value pair of the word would increase by 1 each time our loop came across our word in the transcript. The code would look something like this, where we're looping through, and if we haven't seen a word before, it becomes a key. And if we have seen the word before, we would add a counter to it. With dictionaries, we can start doing some very basic forms of analysis. We could actually make a pretty cool bar chart with word frequencies, or we could aggregate across some other metric. Some other data structures are immutable, which means that they can't be edited. This is generally faster for some different types of operations, and tuples and arrays are like that. Tuples, arrays, and sets are a bit outside the scope of this video, and this video is already going to be really long, so I left some links in the description for my favorite resources if you want to learn more about those. It might have gone under the radar, but we've talked about a couple different types of data already in this video. First, we were talking about text data with a transcript of my video, and then we were talking about dealing with numerical data after we had counted my papayas. We also talked about lists and dictionaries. That takes us to data types, which happen to be very important for analyzing data. As a data scientist, you'll run into many different types of data, and it's important to have a conceptual understanding of them before you analyze them, and as you grow in your career. This is a list of the different data types in Python. As you can see, some of the data structures that I described fall into data types already. Let's go over a few of the most important ones for your career in the data domain. First, we have string. String is text data, and you can see it represented with quotation marks. Simply putting quotation marks around a word makes it a string. Strings have specific characteristics. For example, strings are indexable, so you can take segments of them and iterate through them like lists. You can't, however, change them, so they're known as immutable. You see strings in almost all text data and categorical variables. Dealing with strings and lists of strings is particularly relevant for the field of natural language processing, a branch of machine learning techniques. Next, we have integers. So integers are whole numbers, and we use these to express counts and sometimes also to express categorical variables or rank order. On the other hand, floats are numbers with decimals, so you can run into some issues when you switch between integer and float types. The last data type that I want to touch on is called bools or booleans. These are essentially true and false values. So in Python, booleans can be represented as a 0 or 1, or as false and true keywords. We can use these for binary variables and for classifications. When analyzing data in Python, we need to constantly be aware of the data types that we're using. Using wrong types of data can present problems for our analysis over time. Actually, a big part of coding is avoiding making errors. If we have to write the same code over and over again, we increase the chance that we make errors, and we also have long and gross looking files. The next concept that we focus on allows us to reuse code easily and make our work more scalable. This concept is called functions. Probably unsurprisingly, I get asked the same questions about data science almost every day. Let's take the question, how should I learn to code for data science? If I responded with a full answer to everyone that asked me this, I'd probably have absolutely no time for anything else in my day. On the other hand, if I made a video about it and just shared the link over and over again, people would get the same in-depth answer to this question without me having to spend massive amounts of my time typing. The same concept goes for functions. With functions, you can encapsulate some of your code and reuse it over and over again. Let's take the dictionary example from earlier, where I wanted to get a word count from all the words I use in my podcast. I could write this code in a function and then make it so that I could use that on any podcast that I've ever recorded. Functions work for many things because we can encapsulate code, but also pass different parameters into them. So for example, I could write my code for the word counter like this. So we define the word counter, we pass in the text files that I want to parse, we do the counting for all the words, and then we return the dictionary with the word counts. For functions, you always want them to return something. You don't necessarily have to pass a parameter in. Very closely related to functions are methods. So methods allow us to apply a function or a function-like behavior to specific objects. For example, lists have a method called sort. For a list of numbers, for example, this would put the list in order. These methods are related to objects and object-oriented programming, which is important, but in my opinion, not completely essential to understand for getting started in data. After you get familiar with the other basic concepts, I do recommend brushing up on object-oriented programming, which I discuss just a bit more in depth later in the video. As you can imagine, functions and methods are really important for scaling our work, especially with training and test sets. If we want to do the same things to both sets, like data scaling, functions can come in very handy there. In some sense, the majority of actual coding work is just reusing other people's code. It makes no sense for me to write my own linear regression from scratch every time. Instead, I can import the code from someone else who's probably way smarter than I am and apply it to my specific problem. This is where the concept of libraries comes in. So essentially, a library is a whole bunch of functions that someone else has put together that I can bring in and use for my own work. An example of this would be scikit-learn, which has most of the machine learning algorithms that data scientists use on a daily basis. I can simply import the algorithm that I want to use and apply it in my code. So rather than being functions, these libraries are often made up of a group of objects that have methods that give us our clear desired functionality. To use these libraries, I just download the package to my Python environment using pip or anaconda, and then import the library into my workbook. These are some of the main libraries that are used for data science. So we have pandas and numpy for manipulating data and scientific computing. Pandas has a few data structures like series and data frames that I described before. These are integral for a lot of descriptive analysis that we do in data science. Scikit-learn is the main one for machine learning algorithms, train test splitting, and model evaluation. Matplotlib, Plotly, and Streamlit are very commonly used in data visualization, and things like TensorFlow, PyTorch, and Keras are used for deep learning. I've left all the documentation for all of these libraries and a few videos where I use these tools in the description below. Obviously, there are so many more than just this, but I think those are good ones to get you started. Full transparency, most people usually get stuck at this part. New libraries can be unbelievably confusing, but luckily, Ucode can help you with that. Ucode is the single best, completely free search engine for coders. On your next project, you'll save time debugging because Ucode's sophisticated ranking system is designed to find the most relevant coding results from different sources. You can click to directly copy code from developer-focused apps like Stack Overflow, and you can even use Ucode's suite of AI-powered apps to generate code for languages including SQL, Python, regex, Spark, K8s, and Hugging Face. My favorite part is the ability to easily search and find relevant documentation and peer-reviewed papers. With those concepts, in my opinion, you have a lot of the basics for coding for data science. For those looking to go to the next level, which you should be, these are some of the other relevant concepts that I think can help get you there. So you ran your code and it isn't working. What do you do? Should you just throw your hands up in the air? Should you ask your friend next to you? Should you eat some of those delicious muffins from before? Or should you just give up? The answer is to look at the error messages and begin to understand them. This is one of the most useful skills that you can develop. Generally, you start just by Googling the errors or going to Stack Overflow. But over time, you can learn to debug with just the error messages that you're given. Over time, you can also start writing unit tests and using some other process tools to help you discover inconsistency in your data and your outputs. As I mentioned before, you can also start exploring object-oriented programming to expand your knowledge. Most libraries are structured as a series of objects rather than a series of functions. Object-oriented programming provides increased modularity, reusability, and scalability of code. It allows us to build things around objects rather than individual piecemeal functions. I've left a few of my favorite articles on object-oriented programming for Python in the description below. Once you understand how objects work, you can start understanding all of the logic in the libraries that you use. So I promised a framework for learning any new library or concept that comes your way. This is how I personally approach learning any new tool that I want to work with. Doing this over and over has given me confidence that I can pick up most things and get them working within a few hours. So first, number one thing is look at the documentation. Almost every good library out there has solid documentation, and they're all structured very similarly. So once you get good at reading some documentation, you get good at reading most documentation. Next, look at the examples. Get a feel for how the libraries are used. You can often find examples in the documentation itself, on Kaggle, on GitHub, or on Stack Overflow. After that, I think you should apply the tools on toy problems. So just get them working and tinker around with them. And then finally, apply these libraries on real data. And there you have it, a simple and functional framework. I should note that I use Python as a base language here. This does work for many other languages, although there might be some small differences. Thank you so much for watching and good luck on your data science journey.